moment of inertia of Earth about an axis rotation, about its axis of rotation is given by moment of inertia of Earth. Earth is a solid sphere, so it is given by 2 by 5 mr square. Mass means density into volume. So it is 2 by 5 density into volume 4 by 3 pi r cube into r square. So it will be 8 by 15 rho 5 r raised to 5. 8 by 15 pi r raised to 5. Radii of two uniform sphere of R1, R2, density ρ1, ρ2 has ratio of their moment of inertia. So just like we proved for solid sphere, I in terms of density is 8 by 15, rho 5 r raised to 5. So I1 upon I2 will be rho 1 upon rho 2, R1 upon R2 raised to 5. First and second completed. Third one, a disk rotates horizontally at the rate of 100 revolution per minute. Moment of inertia of disk about this axis is 1 kg meter square. A lump of molten wax having mass of 50 gram is dropped gently at distance of 20 centimeter from the axis of rotation of disk and remains stuck to it. Then increase in moment of inertia will be how much? Who is going to increase the moment of inertia? This mass which falls and sticks at distance r20 is increasing the inertia. More mass, more inertia. So earlier inertia was 1. Due to this mass at distance r, there will be increase. We want percentage increase. Percentage increase is increase upon original into 100. Now, percentage increase is increase upon original into 100. Increase is due to mass mr square. Original is I into 100. Mass 50 gram convert into kilogram. R is 20 centimeter, so 2 into 10 raised to -1 meter square. And I is 1 into 100. Just write this formula. हाँ Completed? Yes, Dhruv, completed?
Hello, sir. Can you hear me?
Ah, I can.
Yes, sir. Continue.
Completed. So we did first, second, third MCQs. Fourth one, a uniform plane sheet of metal in the form of right triangle ABC. BC is greater than AB, AB is greater than AC. However, who will be the longest side if BC is greater than AB greater than AC?
PC.
BC, correct. BC is hypotenuse and AC is the shortest side. That telling moment of inertia will be smallest about which axis? Smallest means mass must be close to the axis of rotation. So longer the axis, more mass is close to this axis. No? So smallest moment of inertia will be about longest axis and vice versa. Who is longest? BC. Hello? Smallest moment of inertia will be about longest because particles are away from small and close to the large. No? Hello? Hello?
Yes, sir.
Moment of inertia means what? Moment of inertia means summation of MIRI square for particles. So more particle I can see they are away from here, but close to BC. Close to BC means R is least. So smallest will be about longest axis. Understood meaning? Hello? Hello?
Yeah.
So
Yes, sir.
smallest about BC clear. About EC will be AC will be largest because particles are away from AC. Away from AC means more distance. More distance means more I. But about BC they are close. Therefore it is smallest. Yes. Can I remove now? Fourth. Can I remove fourth?
Yeah, yes.
Okay. Coming to some number fifth. If I is moment of inertia of solid sphere about an axis parallel to diameter of the sphere. So if this is sphere, this is diameter, I is moment of inertia about axis parallel to diameter. At a distance x, which of the representation is correct variation of I against x? So this is center, this is parallel axis. By parallel axis theorem, I at any point O is I about this parallel diameter plus mass into square of distance. But for sphere, this is 2 by 5 m r square plus mx square. So this is I, this is constant plus mx square. Now I is to be taken along y axis. So this is like y equal to some constant plus mx square. What is highest power of x? Yes, what is power of x? Hello? What is power of x?
2.
2. And power of y? 1. Power of x 2, power of y 1. So this represents parabola, and y ka power 1, y is axis of symmetry. Axis of symmetry means it will divide the parabola into two parts. When I put x 0, I get y equals to constant, which is plus. So when x is 0, y is constant, and this is the shape of parabola. Where this diagram is given, just check, that is our answer. A, no, B, no, C, no, D. Have you followed? Hello? Whenever one variable power 2, other variable 1, then it is called parabola. Power 1 will divide that parabola into two parts. Y ka power 1, दो part पे cut करेगा. But it is not passing through origin, because when x is 0, y is some value, इसलिए थोड़ा ऊपर गया. So therefore this is the answer D. Important part. Completed?
Yes, sir.
Next, sixth one. 4 bodies of masses 2, 3, 4, and 5 kg. 4 bodies of masses, 4 bodies of masses 2 kg, 3 kg, 4 kg, 5 kg are placed at A, B, C, D of the square of side 1 meter. Side 1 meter. The radius of gyration of the system about an axis passing through A and perpendicular to the plane. So axis is perpendicular to the plane passing through A. Whenever you have to find radius of gyration, first step, find moment of inertia. Once you get moment of inertia, you write, but moment of inertia is total mass into radius of gyration and equate. So to get moment of inertia, this mass m1, m2, m3, m4, I want their distances from A. Axis is perpendicular coming out of the board. So first mass, the distance is from the axis 0 or not, because it is passing through that mass. Hello? Hello? First mass m1 from this axis is at 0 distance. Yes or no?
Yes, sir.
Okay. Second वाले का बोलो सोच के. ये एक्सिस ऊपर है, बाहर निकल रहा है, ऐसा दिख नहीं रहा इधर से, परपेंडिकुलर है. So imagine एक pencil रख दिया उधर. From A, what is distance of B? Say, how much is distance of B from A?
B to A.
हाँ, 1 मीटर ना, साइड का डिस्टेंस
Yes.
1 मीटर. 1 मीटर है, इतना क्या सोच रहे हो? R3 कितना है? मतलब एक C का डिस्टेंस A से कितना है?
√2.
Very good. Root 2 into side, which is root 2 into 1. That is root 2 meter. And what is distance of fourth one?
1 meter.
Very good. 1 meter. So I is m1 r1 square plus m2 r2 square plus m3 r3 square plus m4 r4 square. So this will be m1 is 2, distance is 0. m2 is 3, distance is 1. m3 is 4, distance is root 2. m4 is 5, distance is 1 ka square. So this becomes 2 into 0 is 0, plus 3, root 2 square is 2, 2 into 4, 8 plus 5. 8 plus 5, 13 and 3, 16. But I is m total k square. So 16 equals to total mass 3 plus 2 plus 3, 5, 4, 9, 9, 5, 14 into k square. 2 8s are 16, 2 7s are 14 into k square. So k square is 8 by 7, therefore k is root of 8 by 7 is the requirement. Root of 8 by 7, that is option A. First check whether you have understood, then copy. Otherwise, shall I explain again?
Yes, sir, I didn't understand.
Who has not understood? Is it Neja? Neja,
Yes, sir.
what is distance of mass m from A? 0. B is this one. C is root 2, which is length of diagonal. And D is 1. Then once I know R1, R2, R3, R4, I know moment of inertia of particle.
Uh-huh.
है ना? Then
Sir.
after getting I know I is also total mass into radius of gyration square. Okay. Now follow.
Yes, sir. Thank you. sir, done.
Done. Okay. Come to seventh. The moment of inertia of hollow cylinder having mass 10 kg, length 12 centimeter, radius 4 centimeter, about its own axis will be. See, cylinder, hollow cylinder it is. About its own axis means geometric axis. When I cut this into number of parts, it will look like ring. So moment of inertia of hollow cylinder is mr square. ये length का कुछ meaning नहीं है. So m is 10 kg, r is 4 centimeter, convert into meter square. That means it is 10 into 16 into 10 raised to minus 4. So 16 into 10 raised to minus 3. 16 into 10 raised to minus 3 is option.
Yes, sir, done.
Eighth one. About which of the following excess moment of inertia of thin circular disk is minimum? About which excess moment of inertia is minimum? To center perpendicular to the surface. To the center perpendicular to the surface means IC, which is standard axis. We know formula mr square by 2. Second one, passing through center and parallel to the surface. Center and parallel to the surface. Center and parallel to the surface is this. Huh? Is it diameter? I diameter is IC by 2. So right now in A and B, this is minimum. Let us see third one. About axis, tangential and perpendicular to the surface. So this way. That means this will be parallel to IC. IC plus MR square. And third one, fourth one, about tangent in the plane. About tangent and parallel to the surface means it is parallel to the surface. So it is parallel to diameter. So if I call this as A, IA will be I about diameter plus MR square. Who is minimum? Tell me. Which is minimum? Can you tell now? Hello? Which is minimum after looking at ABCD equation? Nobody can hear me? Which is minimum one? Yes,
Sir,
man.
C,
Huh?
D.
B, correct. B is answer, correct.
Yes, sir, done.
Ninth, again, very important. Moment of inertia of circular disc about diameter is I. Its moment of inertia about an axis perpendicular to its plane and passing through point on the ring. Moment of inertia perpendicular to the plane and passing through point on the ring is about this axis below. Amit, this axis is parallel to whom? Diameter or passing through center wala axis?
Passing the center of the axis.
Okay. Any relation between diameter and the center wala?
They're perpendicular to each other.
No, that is true. But I ka formula में I diameter is IC by 2 na?
By 2, yeah.
So I diameter is I. So from this I can get IC is 2I. So if I can arrange my formula for moment of inertia about tangent perpendicular to the plane in terms of IC, I can write, suppose I get IC, then I will write 2I, 2IC, 2 into 2I, 3IC, 3 into 2I, and so on. So IO will be IC plus MR square. Is it correct by parallaxis theorem? Right?
Yes, sir.
IC is nothing but by formula for disk. It is MR square plus MR square. So IO becomes 3 by 2 MR square. But MR square by 2, we all know by this time, for a disk, it is IC is MR square by 2. So moment of inertia about an axis which is parallel perpendicular to the plane and passing through rim will become 3 by 3 times IC, because MR square by 2 is IC. So 3 times 2I, that means it is 6I. Yes, doubt or you have understood?
Yes, sir. I understood.
Okay. Okay.
Yes, sir.
Everybody is done? Everybody is done?
Yes, sir.
10th. Diameter of flywheel is increased by 1%. Keeping mass same, increase in moment of inertia will be mass is kept constant. See, flywheel means disk. So moment of inertia of disk, we know it is mr square by 2. Mass constant, 2 constant. So I can say I is proportional to r square. R and diameter, they are proportional to each other. So diameter increases by 1 means R will also increase by 1. So percentage increase in I is equals to power becomes multiplier 2 times percentage increase in R. This is from our measurement chapter. Percentage increase in I, power becomes multiplier 2 into percentage of R. R matlab diameter same. So it is equals to 2%. Followed? Nija, followed?
Yes, sir. Yes, sir. Done.
What is the moment of inertia of thin ring Whose mass is 2 kg, diameter is 2 meter, rotating about an axis passing through center perpendicular to the ring. So I for ring, axis is standard. So mr square, which is 2 into r, is half of diameter 1 square equals to 2. So answer 2 kg meter square.
Done, sir.
12. Moment of inertia of circular loop of radius r, loop means ring, of radius r about axis of rotation parallel to horizontal diameter and passing through r by 2 distance. So I can say I is I about diameter plus mass into square of distance between two axes. I about diameter is IC by 2 plus mr square by 4. IC for ring is mr square upon 2 plus mr square by 4. So LCM is 4. This is 2 plus 1, so 3 mr square by 4. 3 by 4 mr square is the moment of inertia.
Yes, sir. Done.
Number 13. A rigid body is made up of three identical rods, each of length L, fastened together to form letter H. So one rod, second rod, third rod are joined together to form letter H. We want moment of inertia of this body about axis that runs along length of 1. So this is that one leg. About this axis we want moment of inertia. All the rods are thin. Now can you see here first wale pe rod is thin and this is the axis. So सब particle axis के ऊपर ही है ना almost.
Yes, sir.
So what will be moment of inertia of first one? Moment of inertia is mass into square of distance. All the particles are on axis, so zero, no? Hello?
Yes, sir.
Zero, no? For second rod, is this axis rotating at one end wala? What is moment of inertia at one end? At one end of rod. Last lecture I derived this, if you are remembering. ml square by 3. Yaad hai?
Yes, sir. MS square.
By 3. And for third rod, center of mass is here at the center. And this is one axis in the body. So these two axes becomes parallel.
Yes.
So this will become I about that axis, that is 0 plus mass into square of distance, which is ml square only. So what will be I total? I1 plus I2 plus I3, which is 0 plus ml square by 3 plus ml square. So it becomes 4 by 3 ml square. 4 by 3 ml square.
Yes, sir, done.
14. Four particles, each of mass m, are lying symmetrically on the rim of disk. One particle, two particle, third and fourth, they are lying on the rim symmetrically. So you can consider along the end of diameter. Disk is having mass m. Moment and radius is r. Moment of inertia of system about axis passing through one of the particle and perpendicular to the plane. One of the particle and perpendicular to the plane. So this is axis. Actually, I can see there are four particle and one disk. We want moment of inertia about this axis passing through center, passing through the mass and perpendicular to the ring. So if you consider this as first mass, second mass, third mass, fourth mass. Disk ka mass is here at center. So for disk, by parallel axis theorem, because its standard axis is perpendicular this way, and this becomes parallel to this. I will become I about center plus its mass into square of distance. So it is mr square by 2 plus mr square. So moment of inertia of disk becomes mr square by 2. But along with this, we are having four particles. So for particles, let us see what will be the moment of inertia. For first particle, distance of first particle from the axis, will it be 0? So it is m into 0 square matlab 0. Second particle का distance from this axis, ये perpendicular है. Imagine screen से बाहर आ रहा है ऐसा. From screen it is coming outside like this. Just imagine. So what is this distance?
R.
Root 2r. This is r. This is r. Root 2r. Na?
Yes.
So mass into root 2r ka square. So this will become 2mr square. For third, can you tell me what is distance of this third mass from this axis? From here to here, what is the distance?
2R.
2
2 R.
Correct. So this becomes 4mr square, and I4 is same, root 2r, no? R root 2r. So it will become mass into root 2r square, that is nothing but 2mr square. So total I is disk 3 by 2 mr square plus all this, that is 2m capital R square, 4m capital R square plus 2m capital R square. So I total will become 3 by 2 mr square plus 4 and 2, 4, 8 m capital R square. This much you have followed?
Yes, sir.
But answer is r square by 2 common. So just copy, I will take r square by 2 common. So this will become 3 capital and 16 small. Copy till this so that I can create the space for writing final answer.
Yes, sir, done.
Final answer will be 3, r square by 2 common. This is 3 times capital N plus 16 times. It's 15. Can I rub this now?
Yes, sir.
Some number is 16. 15. Easy. Solid sphere of radius r has moment of inertia I. So solid sphere moment of inertia I, we all know it is 2 by 5 mr square. What will be the moment of inertia of hollow sphere of same mass, same radius? It will be 2 by 3 mr square. That means I of hollow sphere upon I of solid sphere is 2 by 3 mr square divided by 2 by 5 mr square. So 2 mr square cancel, 2 cancel. We get I of hollow sphere is I 5 by 3. So this is nothing but 5 by 5 by 3.
Yes, sir, done.
Next, 16th one, very important. A circular disc A of radius r, circular disc of radius, circular disc of radius r made up of iron plate having thickness T. And another circular plate made up of iron but radius is 4r, radius 4r and thickness is T by 4. The relation between moment of inertia about an axis passing through center of mass and perpendicular to the plane is both are made up of iron. So can I say their density is same?
Yes, sir.
Yes. So if I can get my formula in density R and thickness, then in ratio I can compare their moment of inertia. So first I am finding disk formula in terms of density, radius, thickness, and then taking ratio. For disk, actual formula is mr square by 2. But mass is density into volume, r square by 2. Volume means area of base into thickness into this r square by 2. So rho into area pi r square into thickness into r square upon 2. So rho into pi r raised to 4 into thickness upon 4. Now I of A upon ratio with B, rho will get cancelled because both are same to same. Pi get cancelled, 2 gets cancelled. So RA raised to 4 upon RB raised to 4, TA upon TB is the required ratio. RA is R, RB is 4R raised to 4, TA is T and TB is T by 4. RR cancels, TT cancels. 1 upon 4 raised to 4 is 256. This 4 goes up. So it will become 1 upon 64. 1 upon 64 is obviously less than 1. IA upon IB is less than 1. That means IA is less than IB. This answer. IA less than IB. Yes, everybody has followed again.
Yes, sir.
Yes, please solve them. Yes, completed.
Yes.
Sum number 17. Figure represents an object consisting of hoop. Hoop means ring. Hoop and a rod. Rod is of radius r, length r, and this is hoop. The object rotates about an axis passing through the center and normal to the plane of hoop. Axis passing through center and normal means perpendicular. Then radius of gyration. See, first radius of gyration if they ask means first you find I, then total mass into k square is actually moment of inertia. So this is R. I want total moment of inertia of system. So for hoop, I will be mr square only because it is passing through center perpendicular to this. And for rod, I equals to, it is parallel to the standard axis. This distance is r and this is r by 2. So I about this center will be this plus parallel axis there. So for rod about standard axis, it is m into length. Length is r square upon 12 plus m into distance between two axes is 3 by 2 r the whole square. So it is m r square by 12 plus m, 3 square is 9 upon 4 r square. So LCM will be 12 mr square plus 4 3s are 12, 27 mr square. This is 9. 9 into 3, 27. So 28 mr square upon 12, that is 3 into 4, 3 into 7. mr square by 12 standard excess, then r plus r by 2 is 3 by 2, therefore LCM became 12 and 4, 12 mr square plus 27,
So,
28.
7 by 3 will come now.
4 into 7, 4 into 3, yes, 7 by 4 we cancel, 7 by 3 mr square. So I equals to now total is mr square plus 7 by 3 mr square, correct? So 3 plus 7, 10 by 3 mr square. Total mass means 2m into k square is 10 by 3 mr square. So I can cancel m from both sides. 2 5s are 10. K will be root of 5 by 3 r. In answer, root 5 is not included in root. Total root 5 by 3 r is the answer. That is answer D. So whenever they ask radius of gyration, first always you find I of the system. Then that I is total mass into square of distance. Akansha followed? 17th one?
Yes, sir.
Okay, okay. Yes, 18. Can I start? 17 can I remove now?
Yes, sir.
18. 4 masses are held rigidly by very light circular frame as shown in the figure. What is meaning of light frame? Light frame means mass of the frame is negligible. So this frame has 4 particles on the body, mass m, 2m, 3m, 4m at distance b from the center. What is the radius of gyration of system about an axis perpendicular passing through center and perpendicular to the page. So passing through center and perpendicular to the page, all particles are equidistant. So I can first write I is mb square plus 2mb square plus 3mb square plus 4mb square. So I will be 4, 3, 7, 2, 9 and 10 mv square. So total mass into k square is 10 mv square. Total mass is 10 m into k square is 10 mv square. 10 m cancel, k is same as v. Option. So whenever radius of gyration asked, first find moment of inertia by our standard method for particle mr square. Five masses, each m, are attached to massless disk. Again, same concept. Massless disk means no inertia of disk because its mass is negligible. Five masses, 1, 2, 3, 4, 5 masses are on the ring. Then moment of inertia of the system about an axis passing through center and perpendicular to the ring. That means if you draw a line perpendicular, so all this will become equidistant again. So it will be mr square plus mr square plus mr square plus mr square 5x. So total 5mr square. Okay. Option A.
Yes, sir. Done.
Done. That's all for today. One more lecture will be completing remaining sums also.